All right, section 5.2, we're going to get into a little bit more about what we're looking for as far as different forms that quadratic functions can actually be in. Now we've talked quite a bit about what vertex form looks like, or the form where we kind of have a quantity that's squared and then we have another number being added or subtracted after that quantity, and the different properties and other things that are characteristic of what that looks like. Now what we're going to talk about today is what's referred to as standard form. Now standard form is a little bit different, obviously, and it is a little bit more, I shouldn't say difficult, but it's going to be a little bit different as far as identifying the different parts of a particular parabola and finding the vertex and all that fun stuff. Okay, but a lot of this builds off of what we did in section 1. So if you are okay with doing that, this should transition quite easily for you. All right, so as far as what we're going to do, we're going to define, identify, and graph quadratic functions. Okay, now we already did some graphing. We talked about some of the properties of quadratic functions already in section 1, so we're just going to build on that a little bit. Another thing that we did talk about a little bit in section 1, and we're going to build upon that also, is the whole idea of maximums and minimums when it comes to quadratic functions. And what I mean by that is we talked about if a parabola opens up or down, that is going to indicate to you whether something has a maximum or minimum. And we also talked a little bit about how that affects the range of a particular function. Okay, so we transform things back and forth in the first section. Okay, whether it was reflecting, stretching, compressing, or even just translating something, moving it across the graph, up, down, left, right, so on and so forth. Okay, another thing that we talked about here in the first section was the fact that parabolas are essentially symmetrical, meaning when we were graphing these in the first section, we really didn't worry a whole lot about trying to find both sides of the parabola when it came to filling in values. We just worried about finding one side and mirroring that over to the other side. Okay, now what this slide is basically trying to tell you is we didn't deal a whole lot with reflecting things across the y-axis in the first section because parabolas are symmetrical, and if we reflect it across the y-axis, it's going to look the exact same as it did before. So even if you look at the function that's right here, the graph that's right here, if you take that and you essentially take something here and you reflect it over to this side, you're going to have the exact same point that is the exact same distance away from that dotted line that's splitting your graph in half. All right, so it's symmetrical, and that kind of helps play a big role for us as we move forward here a little bit. Okay, the dotted line that was highlighted on the last slide is referred to as the axis of symmetry. Okay, essentially what it is it is the line that splits our parabola in half. All right, so if you focus down here in the corner a little bit on the picture that's drawn here, that's why when we were graphing in the first section, we just said when it came to filling in x values to our function, we could just stick to x values on one side of the vertex and fill those in. And if I got a point, say that was up here, I could just take and mirror that across on the other side of my parabola because they're symmetrical. Okay, the points would be the same distance away from the line that splits the parabola in half, or the same distance away from the axis of symmetry. All right, now if you look down here at the bottom, and this is also a section that's on your notes, so it wouldn't hurt to fill this stuff in as we go through this. Okay, we talked about finding the vertex in section 1. Okay, the vertex was found by figuring out what h and k were, and we would plot that point, similar to what's plotted over here. Okay, well, we take that one step further and we say, if we know what our vertex is, x equals h represents the vertical line that would split our graph in half. Okay, and remember, x equals something is a vertical line. We talked about this back in the first unit. And y equals something is a horizontal line. So that's why in this case we take the x value of our vertex, which would be our h, and we say x equals that, and that represents the dotted line that splits our parabola in half. All right, so all we're doing with something like this is we still have to find the vertex like we did in section 1, but we just take it and we apply it to something a little bit more than just the vertex being the bottom point or the top point of our graph. So something like this, it says identify the axis of symmetry for the graph of f of x equals negative 1/2. You have x plus 5 squared minus 8. Okay, so really there's not a whole lot of work involved in this. If you remember how vertex form works, the first thing we need to do is we just need to find our vertex. All right, so in this case, my vertex is going to be negative 5, negative 8. Okay, because again, it's opposite in here. If it's a plus 5, that means I actually had to fill in a negative 5 to get that to work based on what the vertex form of the equation originally looks like. So if this is my vertex, and remember our vertex came from HK, and the last slide told us that the axis of symmetry is found by basically taking your H and setting it equal to X. My axis of symmetry is just going to be X equals negative 5. Okay, so again, it's all based on what you get for your X value of your vertex. All right, so X equals negative 5 would be a vertical line going through negative 5 that splits this particular parabola in half. So if we were to graph that whole thing, this would split that graph in half. And rather than doing that by hand, this is just what it would look like if we graphed it on a graphing calculator. And you can see right here, x equals negative 5 is the line that we were supposed to find, which we did. And you can see down here, this is what the parabola would look like. It would open down. And that red dotted line is, if this is the origin, would be 1, 2, 3, 4, 5 to the left, so negative 5. So the vertical line that goes through negative 5 is our axis of symmetry. All right, so what I would like you to do, again, and this shouldn't take real long for you, is pause your video, see if you can figure out how to work this out, and then we'll come back and we'll talk about what you should have got for your results. All right, hopefully you had the chance to go through and work through all this. So again, if I'm going to find the axis of symmetry, all I really have to worry about is, can I find the vertex right away? In this case, my vertex, based on this number and this number, is going to be 3, 1. Okay, again, it's opposite in here. If it's minus 3, that means we just filled in a 3, because basic vertex form says x minus h squared. All right, so 3, 1. So that just means I'm going to take x and I'm going to set it equal to my h value, or basically set it equal to the x coordinate of my vertex, and that is my axis of symmetry. All right, so this is all we need for that particular answer right there. That's my axis of symmetry. Fairly simple. We're just taking the whole idea of the vertex and we're expanding it a little bit based on something new. Okay, now the bulk of what we're going to talk about today deals with writing something that's in standard form. Okay, now obviously you can see, looking at this right here, standard form looks significantly different than what vertex form looks like. Now, the one thing about it is we still do have an A, and essentially A is going to represent the same thing that it did when we dealt with vertex form. But the whole idea here is A, B, and C are just coefficients. They just represent numbers. All right. So what you're going to see, for an example, if I wrote something kind of along these lines, if it looks like this, this is just an example of a quadratic equation that is in standard form. All right. You can see that my A, B, and C are just numbers. Okay, -3, +2, and -1. All right. So basically anything could get filled into those spots. The whole idea is this is what standard form looks like. You have x squared followed by an x term followed by a constant. Okay. Now this, and I don't want you to get too freaked out and worried here if you don't necessarily understand what this is talking about. Okay, this would be a good thing to write in your notes, but more or less it's just talking about the different coefficients here, the A, the B, and the C, and how they relate to something that's in vertex form. Remember, vertex form looked like this. Okay, so we had a little bit different, representation of letters in there. We had an A, we had an H, and we had a K. This time around, we have an A, a B, and a C. Now up here, this just represents how the A, the B, and the C would be related to some type of an expression that we talked about with vertex form. All right, if you're not 100% sure what those mean right now, that's okay. This is just showing you that standard form is in fact related to vertex form. Okay, so first things first, right here, the A, this is just telling you that in standard form, the A does or it represents the same thing that it did in vertex form. And basically what that means is if it's positive, your parabola is going to open up. If it's negative, your parabola is going to open down. All right, it serves the same purpose. Likewise, if A is a positive number, or I shouldn't say positive number, if it's a number like 2, 3, 4, 5, or even negative 2, 3, 4, 5, it represents a vertical stretch. Okay, if it's a fraction between 0 and 1, or between negative 1 and positive 1, like 1/2, negative 1/2, or 1/3, negative 1/3. It just means that we're performing some type of vertical compression. Okay, so again, A behaves the exact same way it did before. All right, now B and C are a little bit different, and this just basically talks about the fact that B comes from dealing with your H and your A in the vertex form of the equation. Okay, what you're really going to want to get out of this slide is the fact that down here, if something is in vertex form, if it's in standard form, all right, it's not going to be as easy to find the axis of symmetry as it was when you were in standard form. In vertex form. All right, so let me say that again just to clear that up. Okay, if you're in vertex form, finding the axis of symmetry is really easy because you just pick out what your vertex point is, and then you set x equal to whatever the h value was. So if our vertex was 2, 3, I know that my axis of symmetry is going to be x equals 2. All right, well, when something's in standard form, like it is up here, it's not as simple to just pick the vertex out of something. So the vertex, finding the vertex is a little bit, more complicated, but finding the axis of symmetry is all based on this part down here that I boxed in. Okay, if you want to find the axis of symmetry when something is in standard form, you just take and you set x equal to negative b over 2a, and whatever negative b over 2a turns out to be, that's what your axis of symmetry is. All right, and we'll get to an example that deals with that here in a second. All right, the last thing would be the c, or the number that's at the end. Okay, again, this up here just talks about how it's related to vertex form or variables from vertex form. We're not going to worry about that a whole lot. But what we are going to do is we're basically going to talk about c similar to like a y-intercept with a linear function. Okay, so essentially whatever c is in this form right here is going to be the point where your graph of your parabola intersects the y-axis. All right, so if I would give you an example like f of x equals x squared minus 2x plus 3, all right, what we'd be looking at there is when I graph my parabola, I'm going to end up with my graph intersecting the y-axis, okay, the vertical axis, at positive 3. All right, so we put all that stuff together. We want to find, basically whether something opens up or down, what the axis of symmetry is, what the vertex is, which we haven't completely got into how to find the vertex if you're in standard form, but we'll get to that here in a second, and what the y-intercept is, okay, or where to find the y-intercept. Now, the most confusing thing on here is probably going to be this, which we'll talk about here in a second. And basically what that is saying is your vertex point, whatever you find when you set x equal to negative b over 2a, is the x coordinate of your vertex. To find the y coordinate of your vertex, you take this x value and you fill it back into your original equation and see what you get out of it. Okay, so essentially you're filling an x value in, you're getting a y value out, and that's how you find your vertex. So it's a little bit longer of a process than it was before. Okay, so again, just to kind of review and think about this a little bit, if A is positive, all right, just like it was when it was in vertex form, your parabola is going to open up, all right, or you can say, this says the parabola is happy. When it's A is negative, or you have a negative in front of your x squared, all right, that means the parabola is sad, or it's just going to open down. So what we're going to do here is we're going to kind of work through this a little bit step by step. Essentially, for each problem, you're probably going to end up finding about 5 or maybe 6 different things about that particular parabola. Okay, and I'm going to split this in a couple different slides as we go through this, and it'll get a little bit easier as you go through it here and make sense of it. So first thing, A, determine whether the graph opens upward or downward. Okay, all we're looking at is the number that is in front of the x squared. Okay, in this case it's positive. So if it's positive, that means my graph is going to open upward, or we can just say up. Okay, so my graph opens up. I figured all that out based on what my A term is. Okay, now find the axis of symmetry. To find the axis of symmetry, I have to set x equal to negative b over 2a. All right, now the whole idea here is, remember, the a, the b, and the c are just the coefficients here. So in this case, my b up here is negative 4. Okay, you have to include the sign that's in front of it, negative 4. So negative 4 over 2 times my a is 2 from the top. Okay, so a negative and negative make a positive, so I have 4 over 4, which is 1. So my axis of symmetry is just going to be x equals 1. Okay, so again, you're just filling numbers in for the b and the c, okay, which come from the coefficients up here. The a comes in front of the squared term, the b comes in front of the x term, and the c is your constant, or the number that has no variable with it. Okay, so that's where we are from there. All right, so it opens up. The axis of symmetry, or the line that's going to split this graph in half, is x equals 1. All right, now taking it to the next step, we have to find the vertex. Now, I'm going to write my axis of symmetry up here, which we found on the previous slide, which is x equals 1. Okay, what I do to find the rest of my vertex, because this is the x value of my vertex. To find the rest of my vertex, my y value from my vertex, I take 1 and I'm going to fill it in to my original equation. Okay, so essentially I'm finding f of 1, or if I fill x into that, what's the y value that's going to match up with it? So I fill everything in here. Wherever there's an x, I'm going to put a 1. Okay, so 1 squared is 1 times 2 is 2 minus 4 plus 5. So 2 minus 4 is negative 2 plus 5 is 3. So when I fill in 1, I get 3. So what that tells me is that my vertex is 1, 3. Okay, so again, a little bit longer process to find the vertex than when something's in vertex form, but it's not really that complicated. Find your axis of symmetry, take that number that you get for your axis of symmetry, and fill it in to your original equation. Okay, that'll match you up with the y value that you're supposed to get with your x value. All right, and the next thing is just going to be find the y-intercept. Okay, well, the y-intercept, we just have to go back and look at this last number back here, the constant, or the c. In this case, it says my y-intercept is just plus 5. So basically, if you want to think about it in terms of a point, it would be 0, 5. Or if you just want to say your y-intercept is 5, you could do that too, as long as you keep track of what that means. Okay, so in this case, your y-intercept is 5. Now we're going to take all that information, all right, a vertex of 1, 3, an axis of symmetry of 1, and a y-intercept of 5, and we're going to use that to help us graph this, and then we'll probably pick a couple extra points as we go through here to make this work. So again, my vertex, we said from the last slide, was 1, 3. My axis of symmetry is x equals 1. And my y-intercept is 5. So I can put all that stuff on the graph right now if I want to. So I will say 1, 3. That's my vertex. We know it's going to open up. I'm going to draw in just this dotted line. And again, this is just my axis of symmetry, which goes through my vertex, which splits my graph in half. I know my y-intercept is 5, so I can put that right here. And what that allows me to do, actually, if it's 5, is I can mirror that on the other side of my axis of symmetry. So already I have 2 points, okay? 1 point on each side of my vertex. So what I'd like to have is at least one more that I could use. So I'm going to think in terms of x values. I already have used 2, and I've technically already used 0 because that would be where these 2 points up here come from. So I'm going to look at something like maybe -1. So what I'm going to do is I'm going to say, I'm going to find f of -1. I'm going to fill that in. Okay, and like I said, the -1, you could have picked any x value you wanted to. I just picked that because it should be somewhat easy to work with here. So when I fill that in, -1 squared is 1, times 2 is 2. -4 times -1 is going to be +4, plus 5. Okay, so 9, 10, 11. So when I fill in -1, I'm going to go all the way up to 11, which is going to be a little bit off my graph, but that's not the end of the world. Okay, and I can mirror that on the other side without having to fill in any other x values. So I get something that looks like that. Okay, so I get a general idea what my parabola is supposed to look like. And you can see based on that, this number out here, my 2, again, in the first section we compared everything to the parent function, f of x equals x squared. All right, in this case, I'm just focusing on not necessarily comparing to that, but we can still compare if we want to. So 2 represents a vertical stretch by a factor of 2. So what that means for my graph here is just the simple fact that this graph that I just drew is probably going to be just a little bit skinnier, or it's going to, go up and rise a little bit faster than the parent function would have. All right, so essentially we're kind of taking all those things and we're putting them together, and that's the way most of your problems are going to look. So I want you to try the same thing with what we have going on here. You're going to go through the same 5 steps that we just did on the previous problem, and you're going to see if you can get this to work out okay on your own. All right, hope you had a chance to do all that. I'm going to run through this quick here just to see if you can check what you got going on. All right, so first of all, whether it opens up or down. Well, you don't see anything out here, so we assume that there's a 1 there. All right, and it's also +1, so we know that our graph is going to open upward. So I'm just going to circle that up here. We know the graph's going to open upward because of the positive sign in front of that. Okay, find the axis of symmetry. All right, again, x equals -b over 2a. All right, in this case, b is 3, so I'm going to go -3 over 2 times, there's a 1 in front there. So my axis of symmetry is going to be -3 over 2, or basically -1.5. Now, not quite as easy to work with as the last one, all right, but we can make it work. All right, so that's my axis of symmetry. Now, we're going to use that same number to find the vertex. Basically, what I'm going to do here is I'm going to take, and I'm going to fill in -3 over 2 in wherever there's an x. Okay, now, if you want to find decimals and you're more comfortable with decimals, that's probably okay. In this case here, I'm going to leave things as fractions because I actually am weird and like to deal with fractions a little bit more. But if you don't want to, certainly you can put this in as -1.5 and go from there. So if I go ahead and I work this out, -3 over 2 squared is actually going to give me 9 over 4 plus I'm going to get negative 9 over 2 minus 1. All right, now, again, it kind of depends on how comfortable you feel with common denominators and stuff like that. I'm going to take this and basically make it negative 18 over 4. So 9 over 4 plus negative 18 over 4. And I'm going to make this minus 4 over 4. Again, if you want to use decimals, that is completely fine with you. We can still compare what you got for your final answer with what I got. So 9 over 4 plus negative 9 over 4 is going to be negative 9 over 4 minus another 4 over 4. It's going to be negative 13 over 4. All right, so I'm going to end up with negative 13 over 4. Now that would be the y coordinate of my vertex. So again, you're looking at what, 3 1/4 probably, somewhere around that line. All right, so vertex, I'll write it up top here, negative 3 over 2 and negative 13 over 4. Or if you wrote a 1.5 and negative, what did I say, 3 1/4 or 3.25, that would be okay too. Now you can see with this, the vertex, not necessarily the easiest thing to work with, but we can go from there. Now D says find the y-intercept. Y-intercept is just this number right here. Okay, so negative 1. So I'm going to plot what I have, and then I'm going to use the other stuff to kind of graph what's going on. So first things first, I'm a realist, but I'm going to put negative 1.5 and 3 1/4. So we're going to kind of have to guess here a little bit. It's going to be in here, roughly in there somewhere. Oh, excuse me, that's the wrong direction. I got to go negative and then down. All right, so let me erase that real quick here. Sometimes I get going a little too fast and get carried away and forget what I was talking about. Okay, so again, we're going to go over negative 1.5 right in here somewhere, and I'm going to go down 3 1/4. So we'd probably be down here somewhere. All right, so that's my vertex. I'm going to open up. Now the next thing I'm going to do is, again, I'm just going to draw my axis of symmetry in here. I'll do the best I can to try to make it look straight. And again, you probably don't have to draw your axis of symmetry in. It's just there for us to show that it splits our graph in half. All right, y-intercept is negative 1. So that means I'm going to be right here when I cross the y-axis. So I can mirror that on the other side. Not the easiest thing in the world to mirror because we have fractions, but decent enough. All right, now I need to pick one more value to use, either on the right or the left, and mirror it across. I'm going to pick 1, just because 1 should be fairly easy to work with here. So let me go ahead and kind of erase some of this stuff down here. And this is not going to be the best eraser job in the world, but to give myself a little bit of room. All right, so we'll just call that good. Still have a little bit of other stuff there, but call it good. So what I'm going to do is I'm going to fill positive 1 in. All right, just because it's an easy number to work with. So 1 squared plus 3 times 1 minus 1. All right, so 1 squared is 1 plus 3 minus 1. So I'm going to end up with 3. So I filled in 1. I got 3, so I'd be up here. Mirror that baby across, somewhere right about in here, and you get a pretty good idea of what your parabola is supposed to look like. Now, the thing about that one that makes it a little bit more difficult, and don't freak out, but you do have some fractions or some numbers that maybe aren't the easiest to work with. Okay, keep going. It's more of a process thing. Do you understand the process that's going on here? Okay, so that's pretty much what the majority of your assignment is going to look like. I got one more thing I want to talk about here, but a majority of it is just going to be problems like that, where you have about 5 different things you have to do and have to find in order to make that work. All right, now we talked about this a little bit, domain and range. The domain of a quadratic function is always all real numbers. All right, the range depends on the vertex and which way it opens, up or down. Okay, so we said if you find the vertex, basically what you need to do is just take the y value of your vertex, and your domain is either going to be y is less than or equal to whatever your vertex number is, or y is greater than or equal to whatever your vertex number is. Okay, and I'll just put K in here because that's what they're supposed to be, or what the y value of your vertex typically represents. Okay, so it just depends on whether it opens up or down. Okay, if your vertex opens up, all right, that means your range is going to look like this. So if you have this kind of graph over here, this is what you're going to have going on. Okay, and your vertex would be a minimum value because it's the lowest point on your graph. If your parabola opens down, like we have over here, then you're going to be looking at something like this. Okay, your domain, or excuse me, your range is going to be y is less than or equal to whatever the y coordinate of your vertex is. All right, so that's what we're dealing with right here. And again, if this happens, as you can see, I have a maximum value. All right, so the reason we talk about maximum and minimum values quite a bit is just for the simple fact that it can help us in some different problems, mostly word problems and stuff like that, as far as figuring out maximum and minimum values. Okay, so the next aspect of this is just figuring out what your maximum or your minimum value is. So again, really all we're doing is we have to find the vertex to start with. So what I'm going to do is vertex, I have to find the axis of symmetry first. So negative b, so negative 2 over 2 times a. All right, so I'm going to end up with negative 2 over 6, so negative 1/3. All right, now again, not the easiest number in the world to work with, but we'll make it work. All right, now from here, in order to figure out the maximum or minimum value, we still have to find the other component of our vertex. So I'm going to have to fill negative 1/3 into this to make this work. All right, so negative 3, negative 1/3 squared plus 2 times negative 1/3 minus 4. All right, now again, just because you get a fraction, don't freak out. All right, a lot of times they tend to kind of work themselves out as we go through this. So we'll kind of see what happens here a little bit. All right, so we fill in negative 1/3. All right, now negative 1/3 should actually be positive 1/3. I'm sorry. Up here, that should have been a negative on the bottom, so that would have been a positive. Sorry, hopefully you saw that before I did that there too. So I'll just change these to pluses here real quick. All right, so not going to really change a whole lot here. In here, negative 1/3 squared is 1/9. So I'm going to get negative 3 over 9. So when I take negative 3 times 1/9, I get negative 3 over 9 plus 2/3 minus 4. All right, now again, negative 3 over 9 is just negative 1/3 if we reduce, plus 2/3. And if I write 4 with the denominator of 3, I'm going to have actually negative 12 over 3. All right, just so we get something we can work through this here. Okay, now negative 1/3 plus 2/3 is positive 1/3 minus this is going to give us negative 11/3. All right, so my vertex is going to be 1/3 negative 11/3. Looks something like this. Okay, now this is what we need to keep in mind if we're going to talk about domain and range and all that. Now again, domain is always going to be all real numbers. So I can write that up here. All real numbers. Domain. Not an issue. All right. Range. Range depends basically on this number here, the y value of our vertex, and whether this opens up or down. Okay, well this right here tells me it's going to open down. Okay, so if it opens down, I basically have to think about my parabola is going to look like this. All right, so if it opens down, I'm going to go y is less than or equal to negative 11 over 3 as far as my range. All right, because if a negative 11 over 3 is right here and we open down, all right, all the y values less than that are going to show up on my graph. So that's my range. All right, and that makes this value right here, or my vertex point, however you want to think about it, it's going to make it a maximum. So I have a maximum value of y equals negative 11 over 3. Okay? So, again, you just kind of have to think about that just a little bit. All right? Now, and this just kind of gives us an indication of where we're working with. This writes it as negative 3 2/3. as far as our vertex value, our y value. Negative 3 2/3 is negative 11 over 3. So we were right as far as figuring all that stuff out. Okay, so again, you can see here, maximum value, all right, and my range is going to be y is less than that, or represent everything going down from there. All right, here's one for you to try on your own here a little bit. Same idea, so why don't you pause, take a look at this, and see what you come up with. All right, now this one should be a little bit easier to work with, hopefully. Again, got to find our vertex. So negative b over 2 times a. Okay, again, negative b, it becomes positive because it's a negative to begin with. So I'm going to end up with 6 over 2, which gives me 3. So already we can see easier number to work with. Okay, I have to figure out what the other part of my vertex is. So I'm going to take that 3 I just found, and I'm going to fill it into the original equation. Okay, so 3 squared is 9, minus 18 plus 3. So it looks like I'm going to get negative 6 here. So my vertex is 3, negative 6. All right. Up here, you can tell that we open up. So my parabola is going to open up. This point down here is going to be 3, negative 6. All right. So as far as my range is concerned, my range is going to be y is greater than or equal to negative 6 because it opens up. The domain, as always, is all real numbers. And this point right here, because it's on the bottom, would be a minimum value. So you could actually write and say your minimum value is y equals negative 6, okay, or the lowest y value that shows up on your graph. Now that should have been quite a bit easier to work with because we didn't have fractions involved there. All right. Now, this is just, again, another graph that shows everything that we just found out. It just puts it in a little bit better context because you can see where the graph would actually be on the coordinate. But you can see it's a minimum, and it's negative 6, which is basically what we came up with. All right. So, now, story problems. All right, story problems are not really any different than what we had before. The only thing that's going to change here a little bit is a lot of times when we're talking projectile motion and stuff like that, we end up with a lot of decimal numbers that maybe aren't ideal to work with, but we can work through it. You just might have to use a calculator a little bit as you go. Okay, so what this is saying is what is the minimum average height of grain and what is the row spacing that results in this height. Okay, basically all you're doing here is you have to find your vertex and you have to determine whether it's a maximum or a minimum, so on and so forth. Now, to start with, you can see right here, this is a positive number, so we know the parabola that would be represented by this is going to open up. So whatever we get for our vertex value is going to be a minimum. All right, so I start the same way I did before. X equals negative b. Well, negative b is actually going to end up being positive 1.28 over 2 times a is 0.024. All right, so if you have your calculator handy, which you're probably going to need to have handy when you do something like this, we're going to take 1.28 and divide it by what we would get on the bottom, which would be 0.048. We get 26.67, okay, as my x value. All right, now basically this is the x coordinate of my vertex, which actually answers this portion of the problem, because that is the x value, or in this case the row spacing, that's going to give me my minimum value. All right, now what we would have to do the rest of the way here is we have to go take this number to find out what the actual minimum is, and I have to fill it in for the variable in all these cases. All right, so now I'm not even going to write this out just because we're going to use our calculator for basically the whole process anyway. So I'm just going to fill this in. So basically I take 26.67 and I'm going to square it. All right, and then I'm going to multiply that by the 0.024 that's in front. Okay, then I am going to take negative 1.28 times the 26.67, which is roughly about negative 34. Alright, so I take my 17.0709 that I got from the first part, I subtract 34.1376 from that, and then I'm going to add 33.6 to that, and I should end up somewhere around 16.5. Now, again, trying to do that all on your calculator, that's the one thing I don't necessarily like about some of these decimal problems. But basically, when I take and fill this number in for R in this case, this is what I get as my output value. So 26.67 and 16.5 represent my vertex point. This being the X value, this being the Y value of my vertex. Alright, well we already said this 26.67 represents the spacing that would need to give me the minimum average height, which this is going to be my minimum average height. So basically, the X coordinate of your vertex represents the row spacing. The Y coordinate, which is going to be your minimum, represents the minimum height of the grain that needs to be planted. Alright, so I do have another example here, pretty much along the same lines. I'll give you a chance to, why don't you pause and work through that, and we'll come back and we'll finish this up so we can finish up this video. Alright, now, same idea here. The only thing that's different is right here, it's negative, so that just means my parabola is going to open downward. Okay? And all that does is for us is that's why it says we're finding a maximum instead. Okay? And the whole, guidelines for the problem is pretty much set up the same way. So first I need to find the X coordinate of my vertex. So negative 2.45. So that would be our negative B over 2 times A, which is going to be negative 0.025. Alright, again, probably going to have to use your calculator on this. Now we should get a positive value. So negative 0.025 times 2 on the bottom gives me negative 0.05. So I'm going to take negative 2.45, divide it by negative 0.05, and we get about 49. Okay, well that's good. We got a whole number, so that should make this a little bit easier. So that would be the X coordinate of my vertex. I have to find the Y coordinate of my vertex, so I'm going to take this number and I'm going to go fill it in for S. Alright, now again, using your calculator is probably your best bet on this. So I'm going to take 49 and square it, and then I'm going to take it times negative 0.025, which gives me right around negative 60, right, or negative 60.025. And then I'm going to take 2.45 times the 49. So I'm taking that negative 60.025 and I'm adding it to 120.05, which I just got. So I end up with 60.025, and then I subtract that 30 at the end, and I get, it's 30.025. I think we're probably just going to call it right around 30. I can write 30.025, but 30 would be okay depending on rounding. Alright, so that would be the Y coordinate of my vertex. So, to answer this question, the maximum mileage would be this number right here, the Y coordinate of my vertex. Alright, and what speed results in this mileage? Right here. 49 miles per hour would give you the maximum mileage for that particular car. Alright, now again, I apologize a little bit for the video getting a little bit long. It's just kind of the way it goes when we're trying to do all those examples and give you a chance to work some out and then come back and work them together. So hopefully this was easy enough for you to understand. Remember, this should be able to give you a good start on your homework. Okay, so after watching this, you should be able to have a pretty good idea of what you're doing, enough to the point where you should be able to get started on your homework before you get to class. Alright? If you have questions, please make sure you ask or bring your questions with you to class when the time comes.